Panelboards are permitted in closets if specific conditions are satisfied according to the National Electrical Code, or NEC. Article 240.24b addresses this. This section likely outlines requirements related to working space, illumination, and dedicated equipment space around the panelboard, ensuring safe access for maintenance and operation. The NEC mandates sufficient working space around the electrical equipment, typically requiring a minimum depth, width, and height for personnel to safely perform tasks such as inspection, maintenance, and repairs. The specific dimensions vary based on the voltage of the equipment and other factors. Adequate illumination is essential for safe work practices around electrical equipment. The NEC typically requires sufficient lighting to enable personnel to clearly see and perform their tasks. Dedicated equipment space refers to the area directly above and below the electrical equipment, which must be kept clear of obstructions to allow for proper ventilation and access. The NEC often restricts the placement of other equipment or systems in this dedicated space. Relay conductors are allowed in the same raceway as other systems if the raceway is adequately sized for all conductors and the relay conductors are properly identified. Article 725.51 likely pertains to the installation of Class 2 and Class 3 remote control, signaling, and power-limited circuits, which often involve relays. Proper identification of conductors is crucial for safety and troubleshooting. The NEC mandates specific methods for identifying conductors, such as color coding or labeling, to clearly indicate their function and voltage. When multiple systems share a raceway, it is essential to maintain proper separation and insulation of conductors to prevent electrical faults and ensure the integrity of each system. Article 725.51 could include requirements for conductor insulation types, ampacity ratings, and rating factors when multiple conductors are installed in a single raceway. The size of the raceway must be sufficient to accommodate all conductors without overcrowding, which can lead to overheating and insulation damage. The NEC provides guidelines for calculating the fill capacity of raceways based on the size and number of conductors. A circuit breaker is allowed as a disconnecting means if it is rated for the full load of the circuit and is accessible and operable from a readily accessible location according to Article 404.9. This section probably addresses switches, circuit breakers, and disconnecting means used for controlling electrical circuits and equipment. The circuit breaker must have an amperage rating equal to or greater than the calculated load of the circuit it protects. This ensures that the breaker can safely interrupt the circuit under overload or short circuit conditions without being damaged. The disconnecting means must be readily accessible, meaning it can be reached quickly and easily without requiring the use of tools or climbing over obstacles. This is crucial for quickly de-energizing a circuit in an emergency situation. Article 404.9 likely includes requirements for the type of circuit breaker suitable for use as a disconnecting means, such as being able to be locked in the open position for maintenance purposes. The NEC specifies requirements for the clear identification of disconnecting means, including labeling to indicate the equipment or circuit it controls. The NEC mandates that the disconnecting means must be operable, meaning it can be easily switched on and off without requiring excessive force or special tools. The NEC addresses the use of circuit breakers as disconnecting means for specific types of equipment, such as motors, HVAC systems, and appliances. The NEC provides guidelines for the proper selection and installation of circuit breakers based on the specific application and load requirements. It is important to consult the relevant NEC articles and sections to ensure compliance with all applicable requirements for panelboard installations, relay conductor wiring, and the use of circuit breakers as disconnecting means. Firstly, regarding panelboards and closets, beyond Article 240.24b, several other NEC articles might be relevant. Article 312 addresses cabinets, cutout boxes, and meter socket enclosures, which are closely related to panelboards. It specifies requirements for working space, conductor bending space, and protection against physical damage. Article 408 covers switchboards, switchgear, and panelboards. It provides detailed requirements for the construction, installation, and protection of panel boards, including overcurrent protection, grounding, and conductor termination. It is crucial to ensure that panel boards installed in closets meet all applicable requirements of these articles to ensure safety and compliance. Secondly, concerning relay conductors in the same raceway as other systems, apart from Article 725.51, Article 300 addresses wiring methods and materials in general. It includes requirements for raceway fill, conductor insulation, and the separation of different voltage systems. Article 310 covers conductors for general wiring. It provides ampacity tables, rating factors, and requirements for conductor identification and insulation. When installing relay conductors with other systems in the same raceway, it is essential to consider the impact of heat generated by the conductors on the raceway fill and the ampacity of the conductors. Proper conductor identification and insulation are crucial to prevent electrical faults and ensure the safe operation of each system. Thirdly, regarding the use of a circuit breaker as a disconnecting means, in addition to Article 404.9, Article 430 covers motors, motor circuits, and controllers. It includes specific requirements for disconnecting means for motor circuits, including the type of disconnecting means, its rating, and its location. Article 440 addresses air conditioning and refrigerating equipment. It provides requirements for disconnecting means for HVAC equipment, including the need for a readily accessible disconnecting means that can be locked in the open position. When using a circuit breaker as a disconnecting means, it is essential to ensure that it meets the specific requirements of these articles based on the type of equipment it is serving. The circuit breaker must be properly rated for the load, readily accessible, and clearly identified to ensure safe operation and maintenance. Article 100 defines terms used throughout the NEC. Understanding these definitions is crucial for interpreting the code correctly. Terms like accessible, readily accessible, ampacity, and disconnecting means are essential for understanding the requirements related to panel boards, relays, and circuit breakers. The NEC is organized into chapters, articles, and sections. Each level of organization provides specific requirements for different aspects of electrical installations. Navigating the NEC effectively requires understanding its structure and knowing how to find the relevant information. The NEC is updated every 3 years. It is essential to use the latest edition of the NEC to ensure compliance with the most current safety standards. Changes and revisions are made to the code based on new technologies, industry best practices, and incident reports. The NEC is adopted and enforced by local jurisdictions. Electrical inspectors are responsible for ensuring that electrical installations comply with the NEC. It is crucial to work with qualified electrical contractors and inspectors to ensure that all installations meet the requirements of the NEC and local regulation. The NEC provides tables for determining conductor ampacity based on conductor size, insulation type, and ambient temperature. These tables are essential for selecting the correct conductor size for a given load. The NEC specifies requirements for grounding and bonding electrical systems to ensure safety and prevent electrical shock hazards. Proper grounding and bonding are crucial for protecting people and equipment from electrical faults. The NEC provides guidelines for calculating voltage drop in electrical circuits. Excessive voltage drop can lead to equipment malfunction and reduced efficiency. The NEC requires overcurrent protection devices, such as circuit breakers and fuses, to protect conductors and equipment from overloads and short circuits. Proper overcurrent protection is essential for preventing fires and electrical hazards. The NEC specifies requirements for the installation of wiring in various locations, including wet locations, hazardous locations, and underground locations. Different wiring methods are required depending on the specific location and environmental conditions. The NEC requires electrical equipment to be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or all. Listing and labeling ensure that equipment meets safety standards and is suitable for its intended use. The NEC provides guidelines for performing load calculations to determine the size of electrical services and feeders. Accurate load calculations are essential for ensuring that the electrical system can handle the expected load. The NEC requires that electrical work be performed by qualified persons who are trained and experienced in electrical installations. Working with qualified electricians is crucial for ensuring safety and compliance with the NEC. The NEC provides requirements for the installation of specific types of equipment, such as transformers, generators, and storage batteries. These requirements are designed to ensure the safe and reliable operation of these systems. The NEC specifies requirements for the inspection, testing, and maintenance of electrical systems. Regular inspection and maintenance are essential for identifying and correcting potential problems before they lead to accidents or equipment failures. The NEC provides guidelines for safe work practices around electrical equipment, including the use of personal protective equipment, or PPE, and lockout/tagout procedures. Following safe work practices is crucial for preventing electrical injuries. The NEC addresses the installation of renewable energy systems such as solar photovoltaic, or PV, systems in wind turbines. These systems require specialized installation techniques and safety precautions. The NEC provides requirements for the installation of electric vehicle, or EV, charging equipment. EV charging stations must be installed in accordance with the NEC to ensure safety and compatibility. The NEC addresses the installation of fire alarm systems and other life safety systems. These systems are critical for protecting occupants in the event of a fire or other emergency. The NEC provides requirements for the installation of communications systems such as telephone, data, and cable television systems. These systems must be installed in accordance with the NEC to prevent interference with other electrical systems and ensure safety. The NEC is a comprehensive document that covers all aspects of electrical installations. Understanding and complying with the NEC is essential for ensuring the safety and reliability of electrical systems. Continuing education and training are crucial for staying up to date with the latest changes and revisions to the NEC. Electrical codes and standards are constantly evolving to address new technologies and safety concerns. It is important to stay informed about these changes to ensure that electrical installations are safe and compliant. The NEC is a valuable resource for electricians, engineers, inspectors, and anyone involved in the design, installation, or maintenance of electrical systems. Consulting the NEC is essential for making informed decisions about electrical safety. The NEC is not a substitute for sound engineering judgment. It is important to consider the specific conditions and requirements of each installation when applying the NEC. The NEC is a minimum standard. It is often necessary to exceed the requirements of the NEC to ensure safety and reliability. The NEC is a living document that is constantly being revised and updated. It is important to stay engaged in the code-making process to ensure that the NEC reflects the latest knowledge and best practices in electrical safety. When addressing panel boards and closets, ensure the working space in front of the panel board is clear and meets the NEC depth, width, and height requirements. This space allows electricians to safely access and work on the panel board. Proper illumination is vital. The NEC requires sufficient lighting in the vicinity of the panel board to enable safe and effective work. The panel board should be readily accessible. It should not be blocked by stored items or other obstructions. Dedicated equipment space above and below the panel board needs to be maintained. This space should be free of any piping, ductwork, or other equipment. The panel board enclosure should be properly grounded. Grounding protects against electrical shock and ensures the safe operation of the panel board. Overcurrent protection devices, such as circuit breakers or fuses, should be readily accessible and properly labeled. This allows for quick identification and isolation of circuits. The panel board should be suitable for the environment in which it is installed. If the closet is damp or wet, a panel board rated for wet locations should be used. Wiring entering the panel board should be properly secured and protected from damage. This prevents loose connections and potential electrical hazards. The panel board should be installed in accordance with the manufacturer's instructions. Following the manufacturer's instructions ensures proper installation and operation. The panel board should be inspected regularly to ensure that it is in good condition and that all connections are tight. Regular inspections can help identify and correct potential problems before they become serious. When dealing with relay conductors in the same raceway as other systems, ensure the raceway is sized correctly to accommodate all conductors. Overcrowding can lead to overheating and insulation damage. The conductors should be insulated properly to prevent electrical shorts and ground faults. The insulation ratings should be appropriate for the voltage and temperature of the conductors. Different voltage systems should be separated within the raceway. This can be achieved by using barriers or by maintaining a minimum separation distance. The conductors should be identified clearly to distinguish them from other systems. Color coding, labeling, or tagging can be used for identification. The raceway should be grounded properly to provide a path for fault current. Grounding protects against electrical shock and ensures the safe operation of the electrical system. The raceway should be supported properly to prevent sagging or damage. Support should be installed at regular intervals in accordance with the NEC. The conductor should be installed in a neat and workmanlike manner. This helps prevent damage to the conductors and makes troubleshooting easier. The raceway should be protected from physical damage. It should be located in an area where it is not likely to be struck or damaged. The raceway should be inspected regularly to ensure that it is in good condition and that all connections are tight. Regular inspections can help identify and correct potential problems before they become serious. When using a circuit breaker as a disconnecting means, ensure the circuit breaker is rated for the full load of the circuit. The amperage rating of the circuit breaker should be equal to or greater than the calculated load of the circuit. The circuit breaker should be readily accessible. It should be located in a place where it can be easily reached and operated. The circuit breaker should be operable. It should be easy to switch on and off without requiring excessive force or special tools. The circuit breaker should be identified clearly to indicate the equipment or circuit it controls. Labeling the circuit breaker helps prevent accidental disconnection of the wrong circuit. The circuit breaker should be lockable in the open position. This allows for safe maintenance and repair of the equipment or circuit it controls. The circuit breaker should be suitable for the environment in which it is installed. If the environment is damp or wet, a circuit breaker rated for wet locations should be used. The circuit breaker should be installed in accordance with the manufacturer's instructions. Following the manufacturer's instructions ensures proper installation and operation. The circuit breaker should be inspected regularly to ensure that it is in good condition and that all connections are tight. Regular inspections can help identify and correct potential problems before they become serious. The circuit breaker should be tested periodically to ensure that it is functioning properly. Testing can help identify and correct potential problems before they lead to accidents or equipment failures. Furthermore, consider the specific occupancy and application when applying the NEC requirements. For example, the requirements for panel boards in closets may be different in residential, commercial, or industrial occupancies. Similarly, the requirements for relay conductors and disconnecting means may vary depending on the type of equipment or system being served. Always consult the applicable NEC articles and sections to ensure compliance with the specific requirements for the installation. Proper planning and design are essential for ensuring safe and compliant electrical installations. Before beginning any electrical work, develop a detailed plan that includes load calculations, wiring diagrams, and equipment specifications. This plan should be reviewed by a qualified electrical engineer or inspector to ensure that it meets all applicable requirements. Use high-quality materials and equipment that are listed and labeled by a recognized testing laboratory. Avoid using substandard or counterfeit products, as these can pose a serious safety hazard. Follow safe work practices at all times when working with electricity. Wear appropriate personal protective equipment, such as gloves, safety glasses, and insulated tools. De-energize circuits before working on them whenever possible, and use lockout/tagout procedures to prevent accidental energization. Never work alone on electrical systems, and always have a qualified person nearby who can provide assistance in case of an emergency. Remember that the NEC is a complex and comprehensive document. It is important to have a thorough understanding of the code and to consult with qualified professionals when necessary. Staying up to date on the latest changes and revisions to the NEC is essential for ensuring that electrical installations are safe and compliant.